In the previous video, I referred to this collection of notes here as something called the chromatic scale. And it might be helpful to expand on exactly what I mean when I call something a scale. So for the purposes of this video right now, a scale is an ordered, and ordered is extremely important, an ordered list of notes across all octaves. So when I say that the chromatic scale has the note C in it, what I actually mean is that it has the note C0, C1, C2, C3, etc. all the way up. And when I say it has C sharp, it has C sharp 0, C sharp 1, C sharp 2, etc. So when I write a scale that has a note with no octave number in it, you can just assume that to mean that it refers to the note in every octave. And a piano, for example, is just a series of chromatic scales arranged next to each other. So this section right here would be one octave of a chromatic scale. And it goes C, because C is the lowest frequency, it's the first note, then D, E, F, G, A, B. So all the white keys are the whole letters, and then C sharp, D sharp, F sharp, remember no sharp between E and F, G sharp, A sharp. And the piano is just an arrangement of these chromatic scales in sequence up octaves. So this chromatic scale right here would be one octave. It would be one octave up of the previous octave. And this keyboard, for example, has 5 octaves total. Most pianos, like the Steinway pianos that you'll see, are 7 octaves, but you can have pianos in any sizes. Likewise, if we looked at a guitar, if you held down this string on this fret and played it, this would be an F note. And then if you held down this fret, this would be F sharp. And then this would be G, and this would be G sharp. And it would just continue going up until you reach the 12th fret, which would be E, which is an octave up than if you just played the top string without holding down any frets. And this goes on and on throughout the entire guitar. And I think the average guitar is tuned to E2 as the lowest bass note. So just playing this string open is E2. And then the 12th fret here would be E5. So that's a range of 3 octaves. And then depending on what kind of guitar you have, there's additional frets past the octave on the lowest string. So this can go past C6. So normally you'll have like 3+ octaves on a guitar. And likewise, if we looked at a bass, you would see that it is arranged very similar to a guitar, only this open string here is tuned an octave lower. So this is tuned to E1, which means that all of these notes up here are not notes that a guitar can play. They're all lower frequencies. So you can see that all of Western instruments are just different arrangements of the chromatic scale in different form factors and then tuned to different octaves so that they can produce the notes in different frequencies. We can think of the chromatic scale as a list of all notes because it contains every note that's on an instrument like a piano or a guitar. But oftentimes, and I would say almost most times that we're playing music, we're not concerned with every single note in the chromatic scale because we want to focus around one musical idea or one melody or one chord progression or something. So the scale that we're actually concerned with is going to be smaller than just the chromatic scale. If you've ever done any work with data structures, you can recognize that this chromatic scale that I've outlined, we could call an array because it's an ordered list of a fixed length. And when you have arrays, there's a couple manipulations you can do on them to change what is inside of them. One thing you can do is what's called a sort. A sort is when you take an array and you change the order of the elements without actually changing the elements that are inside of it. Another thing you can do is what's called a filter. A filter is when you take one array and without changing the order, you only select certain elements for it so that you end up with an array of a smaller size. So if we only took the first 3 elements of the array, we'd end up with C, C sharp, and D of size 3, and that would be called a filter. And by sorting and filtering this chromatic scale in predictable ways, we can generate smaller scales that we're going to use all the time in music. One of the ways that we can start to classify these subscales is going to be by the length of the scale. The chromatic scale is of length 12 within an octave. But the most common scales that we're going to work with in music are what are called heptatonic scales. And if you have, ever studied Latin, you would know that hepa means 7. So these are scales that have 7 notes in each octave. And by far, the most common heptatonic scales that you're going to see are what are called the major scale and the minor scale. And I think it's easiest to just explain what major and minor mean by just showing an example. So let's look at the E major scale. And you could see that term E major is composed of two words, the letter E and then the word major. For all intents and purposes, we can think of when something says that a scale is in E, of this being a sort on that chromatic scale. And we're going to sort the array such that the letter E is in the first position of the array. So we could think of making a transformation on this chromatic scale. So instead of starting on C, it preserves the exact same order, only it starts on E. So it would go E, F, F sharp, G, G sharp, A sharp, B, C, C sharp. So still an array of length 12. And these would have indexes. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, I forgot D and D sharp. So D, D sharp, 11, and 12. And then the term major you can think of as a filter on that array. So we're going to filter the sorted array, and we're only going to take elements 1, 3, 5, 6, 8, 10, and 12. So if we do that, we will end up with E, F sharp, which is 3, 5 is G sharp, 6 is A, 8 is B, 10 is C sharp, and then 12 is D sharp. And this scale here, which is also ordered and all the elements also have indexes, this 7-length scale here is the E major scale. And the E major scale, or any scale of length 7, is what you hear when people sing do, re, mi. They're going do, re, mi, fa, sol, la, ti, and then E in the next octave would be the do again. So you're familiar with that concept of 7-length scales. Let's do another example just to make sure that we completely have this idea down. So instead of looking at E major, we're going to look at A major. So let's generate the A major scale and see how we would do that. So we go A sharp, B, C, C sharp, D, D sharp, E, F, F sharp, G, G sharp. And this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And we're making A major because major just means the filter on the sorted array. We're going to keep that same filter, and we're going to take elements 1, which is A, then 3, which is B, then C sharp, D, E, F sharp, and G sharp. And this new array is the A major scale. So major is just referring to a filter. A is just referring to the thing that's at the first index of the array. So now let's look at, instead of A major, we're going to generate an A minor scale. So not major, but minor. So minor, if you can figure this out already, is just referring to a different filter on this sorted array than what major is referring to. So instead of taking those elements, we're going to take elements 1, 3, 4, 6, 8, 9, and 11. And that's going to leave us with A, B, C, D, E, F, and G. And the A minor scale is really cool because there's no sharps, which mean that it's all the white keys on a piano. So if you want to play a piano song in A minor, all you'd have to do is just use all the white keys and never touch any of the black keys. I had mentioned that a scale we can think of as an ordered array of notes. So for example, if we look at C sharp minor, that's going to be C sharp, D sharp, E, F sharp, G sharp, A, and B. And these are going to be indexed because they're in a very specific order. Well, there's another data structure that we can use called a set. And a set is going to represent an unordered collection. So we can wipe away the indexes, and I'm going to represent a set with this pound and then squiggly bracket syntax. And this is going to represent an unordered collection of notes. So all these 7 notes, but just in any order. The order doesn't matter. And we're going to introduce another term called key. And a key is, instead of representing an ordered array, is going to represent an unordered set. So when we think of the key of C sharp minor, we're talking about the collection of notes, but the order is just not important, what order that they're in. I'm going to introduce another term now called melody. A melody, for the purposes of this screencast, we can think of as an ordered array of notes. And obviously, you can play multiple notes at the same time in music, but to simplify this, we're going to think of a melody very specifically as just individual notes in sequence. So I'm going to construct a very simple melody right now. It's going to go D sharp, then B again, then A, then C sharp, then F sharp, and then C sharp. And we could then ask the question, is this melody in the key of C sharp minor? And we could think of the way that we would do this as a very simple mathematical operation, which is to look at each individual note and look and see if that note is contained in the set of items of C sharp minor. So we look at each individual note. Each individual note is in this collection. So we could then say that this entire melody is fully contained by the key of C sharp minor, which means that the melody is in the key of C sharp minor. And that's going to be a really important concept. Also, if we just took a look at this and say we change this A to A sharp, well, now this A sharp is not contained in the notes of the C sharp minor scale. So because it's not contained, this is now no longer in the key of C sharp minor. This is now in a different key. And this is, to an extent, a slight simplification of how keys work, but for all intents and purposes, it's correct. And I'm going to show you a couple examples just to hammer the point down that I'm trying to make here. So I'm going to pop into Ableton for a minute now. If you've never seen Ableton before, you can think of it a little bit like Photoshop, only instead of manipulating images, you're manipulating music. And we're going to look at the opening melody to the song Slide by Calvin Harris. So let me pop that open and I'll show you what it sounds like. So that was a representation of that melody as an analog audio signal. But we could also look at a digital representation of individual notes. So this is a MIDI map of each note in the melody that I made. And let's listen to that real quick and see what that sounds like. So even though this melody contains 24 separate notes, if we fold all the notes down together, we could see that there's only actually 8 different notes being used in the melody. And then each of those 8 individual notes is actually contained in the key of C sharp minor, just across 2 separate octaves. So we could say that this melody is being played in the key of C sharp minor. So now here's an interesting thought. We said that this melody is in the key of C sharp minor. And if we look at the C sharp minor scale, it goes C sharp, D sharp, E, F sharp, G sharp, A, and B. And these are indexed as 1, 2, 3, 4, 5, 6, 7. If we look at the first part of the melody, so this thing right over here, we could see that it is E, then F sharp, then G sharp, then F sharp, then E, and then C sharp. But we could also, instead of looking at this melody as the concrete implementation of it, we could look at it as the abstract representation of what indexes in the key it is. So instead of saying E as the first note, we could say that the first note is the 3 of the key. And then this F sharp is the 4 of the key, and then the 5 of the key, and then the 4 of the key, then the 3 of the key, and then the 1 of the key. So if you've ever done any kind of math or computer science, this idea might be familiar to you, that you can have an abstract representation of some data structure and then a specific implementation of it later downstream, but you can work against the abstract representations. If you've never done any math or computer science, this might be completely unintuitive to you, but just bear with me for a minute. So here's an interesting idea. We looked at A minor also, and we said that A minor was just A, B, C, D, E, F, G. And these are indexed in A minor as well. So would it be possible to take the abstract representation of this melody and implement it in A minor instead of C sharp minor? Sure, because all that you would need to do is, map the 3 of the key. So we would say that that's C, and and then it would go to D, which is the 4, and then E, then back to D, back to C, and then land on the 1, which is A. And then this representation here is that exact same melody, only the melody is in A minor instead of C sharp minor. And this is a concept in music called transposing. So transposing. And you can transpose melodies into different keys, which is a really interesting idea that's going to be extremely important. And now I'm going to unfold this map, and I'm going to highlight every single note, and I'm just going to move them all down so that this this root note here lands on A instead of C sharp. And you can see that the transposition worked exactly as we mapped it out. It goes C, D, E, D, C, A. So let me play this just so you can hear what it sounds like. So if I wanted to play this riff on a guitar in C sharp minor, it would look like this. And now, if I wanted to play that exact same riff in A minor, all I would need to do is slide my hand down to start on a different note, which is the 3 of the A minor, or C in this case, and I would use the exact same fingering. So it would sound like this. And that's why people say that guitar is simpler than a piano from a music theory perspective, because all that you're doing to transpose keys is using the same finger positions but just sliding down and up. Whereas on a piano, you have to use different fingering positions for different keys. So that was a simple melody that was 24 notes long, but you can have much more complex melodies that are all still contained within one key as well. So let's look at an example. This is the melody to the chorus of Despacito. And you'll see that this is over 100 notes long, but the entire thing is still in one key. In this case, it's the key of B minor. So that would be B, C sharp, D, E, F sharp, G, A. And you can see the notes that are used in the melody here. So it's 10 notes across 2 separate octaves. But out of these 10 notes, you can see a very complex melody. It's 4 times the length of the slide melody that we looked at, but it's all still contained in one key. So I'm going to play this melody real quick at the actual speed that it is performed at. And if you want to fast forward, you can fast forward a minute. But I think it's interesting to listen to how a much more complex melody could still be contained within a small subset of notes. So those 7-note major minor scales are used all the time in modern music, but they aren't the only scales that are extremely common. So in addition to those heptatonic scales, we also have what are called pentatonic scales. And if you know your Latin, then penta, right, you would know means 5. So these are scales that are 5 notes per octave, and these are also extremely common in music, and we're going to see something really interesting as we dive into this. So let me quickly make an example, and we're going to look at the example of F sharp, and we're going to look at F sharp major. But we're not just going to look at F sharp major, we're going to look at the F sharp major pentatonic scale. Pentatonic. So if we forget the pentatonic for a second and just look at the normal F sharp major scale, we'll remember that this is 1, 3, 5, 6, 8, 10, 12 of the chromatic scale. And I'm going to quickly number these just for convenience without having to sort the array by hand. So 4, 5, 6, 7, 8, 9, 10, 11, 12. And if we constructed the F sharp major scale, we would end up with F sharp, G sharp, A sharp, B, C sharp, D sharp, and F. So it'd be 1, 2, 3, 4, 5, 6, 7. And the way that we have an absolute filter on the chromatic scale, we also have a filter for the major pentatonic scale, which is 1, 3, 5, 8, and 10. So this is the 5-note major pentatonic scale. And if we see what it looks like, it would look like F sharp, which is 1, G sharp, which is 3, the 5 is A sharp, the 8 is C sharp, and then the 10 is D sharp. And then this is also indexed 1, 2, 3, 4, 5, and this is our major pentatonic scale. But there's going to be something that's really interesting here, is that this entire 5-note pentatonic scale is actually a subset of this 7-note major scale here. So the pentatonic scale is fully contained in the key of F sharp major, which gives us some really interesting kind of musical things that we can do. For example, you can play a melody in the key of F sharp major. So you are playing fully in the key of F sharp major, and then you can dip down into the pentatonic scale and start playing in the F sharp major pentatonic scale without actually leaving the key. It just means that you're getting rid of these two notes. You're not using this B and this F. And then you're just playing the pentatonic scale, and then you can come back up and introduce that B and the F and start playing in the major scale again. So this is a really interesting idea, that you can have scales that are fully contained subsections of other additional scales. And we're going to see this idea recurring later in this series. But just for now, that's really interesting. We're going to look at another pentatonic scale also. So let me quickly just erase this guy. And the way that we have these major pentatonic scales, we're also going to have minor pentatonic scales. So we'll go back to our friend A minor, because A minor is super simple because it's all the non-sharp notes. And this has a pentatonic also. Pentatonic also. So we said that A minor we knew was A, B, C, D, E, F, G. And these are 1, 2, 3, 4, 5, 6, 7. And the pentatonic is going to be 1, 4, 6, 8, and 11. And that will give us A, and it would give us C, D, E, and G. So this would be the A minor pentatonic scale, which is also fully contained in the A minor scale, the normal A minor scale. Well, here's something else that we could look at maybe that's kind of interesting. So instead of looking at the pentatonic scale as an absolute filter on the chromatic scale, we could look at it as a relative filter on the minor scale. So we could say, once we already have this minor scale generated, let's just take items 1, 3, 4, 5, 7 from the minor scale. So if we're just taking these elements out of the already existing minor scale, well, that's how we could end up with this pentatonic scale. And that's an interesting idea too, is to start thinking about the scales and how you construct them as relative to already existing scales when you're making subscales. So maybe that will help with your memorization, because it's going to become important probably to memorize these scales if you're going to play any instrument or create any music. So that's just one approach. And just to take a look at what a pentatonic melody sounds like, this is the opening melody to the song Across the Room by Odessa. So let's give that a listen. And if we look at the MIDI map, we'll see that there really are only 5 different notes that are being used in that entire melody. And it's interesting that we can make these robust sounding melodies with much tighter constraints, in like a pentatonic scale where we can only use 5 different notes. So the pentatonic scales are really cool. There's a meme when playing guitar that if you don't know how to generate a melody or you don't know how to play a solo, just start randomly playing notes in a pentatonic scale and it'll probably sound pretty good. Those minor pentatonic scales are used all the time in blues music. That's what blues music is based off of. So there's a lot of exploration there. Okay, there's one more point that I want to highlight before I end this video. Thus far, the way that I've been showing you how to generate major and minor scales is as an absolute filter on the chromatic scale. So for example, if we wanted to make the minor scale, we go 1, 3, 4, 6, 8, 10, 11. And our A minor scale, that's our friend, would be A, B, C, D, E, F, G. And we call this an A minor scale. Well, there's actually another way you can think of generating this scale. So assuming that we know that the 1 is on A, instead of thinking of this as an absolute filter on the chromatic scale, we could think of it as a relative filter relative to A. So instead of this array, let's think of a new array, which is how many steps up we have to go from A to generate the next note. So going from A to B is 2 steps. So we just write 2 here. Going from B to C is 1 step. So we'd write 1. And then C to D is 2. D to E is 2. E to F is 1. And then F to G is 2. And then G to A is 2. So we could actually think of a minor scale, right? A minor scale as this transformation, which is the relative step you need to take from each note to get to the next note in the scale. And you can think why this would be kind of useful if you're, for example, playing a piano where all the notes are arranged horizontally in one direction. So you know, oh, I'm playing the A minor scale. I'm on a note that I know is A. I just need to go 2, 1, 2, 2, 1, 2, 2, and I know the finger positions to play that entire scale. That can be kind of useful. Something else to note that might get a little confusing. You might see these terms pop up that are called tones and semitones. I think this notation is really confusing, so I try to avoid it, but I will just say what it is. So in music, a semitone is 1 note. So it's a 1-note interval between notes, and a tone is a 2-note interval between notes in the chromatic scale. So for example, you might see this said that from F sharp to G sharp is 1 tone, right? Because it's 2 notes. There's a 2-note interval. It goes 1, 2. And then you might see someone say, well, from D to D sharp is a semitone, right? Because it's only a 1-note interval. So you might see, instead of 2, 1, 2, you might see this written as tone, semitone, tone, tone, semitone, tone, tone, to represent the interval that you go up when you generate a minor scale. Well, I think this is so confusing because tone seems like it should be the atomic unit because it doesn't have any prefix. And semi seems like it should be like 0.5 of something. Like, why would the atomic unit represent 2 steps? I think it's kind of confusing. So I try to avoid thinking in terms of tones and semitones and just use numbers because I hate fractions. But I just wanted to highlight the point that you might see that syntax. So that is a quick introduction to scales and keys in music. But thus far, we've only looked at scales and keys in isolation. We haven't actually explored the relationship that exists between different scales and keys. And that's what we're going to look at in the next video.